Welcome to the part 1 in Deep Dive in Asynchronous Programming series. This part is for persons who never used async await before. If you are here for deep dive, please feel free to skip this part and start from part 2. Let's get started. Here is a console app written in .NET 5. Let's start by writing a console log at start and end of the application. Also, we can have a stopwatch to measure the time it takes to complete our application. In order to demonstrate asynchronous programming, first we need to have a method that takes long time to complete. To do that, I will start by writing a method called doTaskA. Inside that method, I will have console log at start and end of the method to understand when the corresponding task is started and completed. To write the code that takes long time to complete, I will have a for loop that runs for 100 million times. Inside the for loop, we will create a new GUID every time. Call this method in the main method. We can run our application and see what happens. Here we can see that our application is started and also our long running code is also started. Let's wait until the long running code completes. It got completed. We can see the console write line. Also we can see that it takes 10 seconds to complete. To demonstrate asynchronous programming properly, at least we need two methods that take long time to complete. So I will duplicate this method and create a new method called doTaskB. We can call this newly created method in the main method below our original method. Let's start the application once again and check what happens. We can see that our application has started. Also the first method is also started. Let's wait until it completes. Here it got completed and the second method got started. And let's wait for the second method to get completed. Here it got completed. We can see it takes 20 seconds to complete. This is all well and good, but do you guys notice the first code and second code has no dependent logic? So theoretically we can run both the code parallelly. Here asynchronous programming come into the play. Let's start by converting our synchronous method into asynchronous method. To do that, in our case, first we need to create a task that runs our long running code. For that, we can take the help of task.run method. Just we can give task.run and in the lambda expression, we can pass our long running code. We can do the same for the below method as well. Let's run our application and see what happens. Wow, what the heck? Our application completed in 0.03 seconds. How is that possible? From our previous testing itself, we know a single task will take 10 seconds to complete. So something is wrong. If you notice, our both task has been started, but it's not completed. This happened because when we convert our long running code into a task, by default, the caller doesn't know when the corresponding code will get completed. In this case, our both method have been started since the caller, in our case is the main method, doesn't know when the corresponding code got completed. The main method got ended. So it in turn closed our application. To correct this, we need to explicitly say we need to wait until the corresponding code got completed. For that, we can use await keyword. To do that, just we can give await in front of our task.run method. You can notice it shows an error. This is because We should always use await only if it is an asynchronous method. So we need to convert our current method into asynchronous. To do that, we can simply give async keyword in front of the return type. And asynchronous method should always return task. So we need to change the return type from void to task. Also, by naming conversion, we need to always end our asynchronous method with async name. So we can change our method name to do task a async. We can do the same for the other method as well. Now we have given await in our inner method. So our inner method will be waiting until the corresponding task got completed. But if you see in main method also should wait until our inner method get completed. So in our main method also we need to give await in front of our asynchronous method name. Since we are giving await, as usual we need to give await in our method and return type as task. Since this is a main method, we don't need to change the method name. Now let's run and see what happens. Here task A is started, but our task B is not started. Let's see what happens. Now you can see task A is finished, then only task B is starting. Now it got completed. So what's wrong? If you see, our main method has two awaits. When the code execution hits the first await, it will wait until the corresponding task gets completed. After that only, it will call the second method that in turn starts the second task. But we don't want that. We need to have both the tasks running at the same time and wait later for the both tasks to get completed. How can we do this? It's very simple. First, we can go and remove the await. Remember, every asynchronous method will and must return task. Yeah, we can create a variable to store that task. We can do the same thing for the second task as well. Now we need to await both the tasks separately. Now, if you see our code, we are initially calling both the task. After that only, we are waiting for the task to get completed. Let's run and see what happens this time. If you see, our both the task has been started as expected. Now both the task has been completed together as expected. Let's see what happens if one task take lesser time to complete. So I will change the second task to take lesser time and run the application and see what happens. You can see both the task has been started and the second task ended first itself. After that only the first task has ended. So it's running as expected. Writing separate await for each task looks complicated and less understandable. Luckily, there is a built-in method called task.whenAll that will wait until all the tasks that is passed to that corresponding method completes. Let's rewrite our code and delete our old code. This will give the same result as before. To conclude, we can take a look at the real world scenario. The requirement is we need to request to a web server and write the response of the web server into a file. I will start by writing a separate method that returns a string since the web server's response is a string. In that, we can create an instance for HTTP client and we can use get string async method to send request to the server. If you notice, that method ends with async word. This means this is an asynchronous method. So we have to give await in front of that method. And also we need to convert the current method to asynchronous method. But this time we have return type as string. So we need to change this to task of string. Now we can call this method in the main method. Next, we need to write the response into a file. But for writing the response into the file, first we need to wait until we get the response from the server. So we can give await in front of the method and assign the response into one variable. To write a file, we can use file.writeAllTextAsync method. This is also asynchronous method, so we should give await in front of it. Let's run the application. Application has been completed. Let's open the file and check whether the content has been written. Yeah, the content of the website is written in the file. That's it for this video. Let's quickly recap the important points from this video. First, we need to give await keyword in front of a task in order to wait till it's complete. If there is multiple tasks that can be awaited parallelly, then we can use task.whenAll method. The await keyword must only be used within asynchronous method. Asynchronous method must return a task. Asynchronous method's name should end with async word. If we make a method async, then its caller must be async. After that, we should make that caller's caller method async. In short, we need to make the whole chain asynchronous. That's it for this video. Make sure to watch part 2. From part 2, it will be deep dive into asynchronous programming. Make sure to like this video if you liked it, dislike this video if you dislike it, write in comment what you liked and what you don't like, and for any future suggestions. And most importantly, if I do any mistake in this video, write it in the comment section. I will correct it as well as pin that comment, and subscribe to stay up to date in .NET. See you soon.